This is Stefan Mozart from the IEEE Consumer Electronics Society. With me I have Kees, Immink, who's well known for his contributions towards the optical storage devices like CD, DVD, etc. And Karlheinz Brandenburg, who's well known for his contributions to MP3, to audio coding. We want to briefly discuss the issues of audio testing. You know, how do you know your technologies are good? How do you know making improvements? You must have some way of testing the sound quality. You know, and I think there could probably be similarities, but also differences between how do I evaluate a compact disc for audio quality, how do I evaluate something I've been want to transmit on a telephone line, for example, and audio quality. So maybe you start with Karlheinz.
Yeah, anyway, I see a lot of commonalities, because at least in the case of high quality audio coding, we have a clear reference, and that's what we got on CD or any other digital medium, which is really high quality. So from the early days on, it was clear from the way these systems work that we have to do testing by people. Sometimes this is called subjective testing. That's not really clear. We want objective results. By doing the test in a way that it's valid, that it's repeatable, and so on, all these criteria. So we want to get real statistics, that we have confidence that there's no problem. It was once said that if you take a 16-bit D2A converter and feed it with audio, you might find somebody who calls that music.
I see.
So there's no way just from the statistics. So to find out what we can do, we need the properties of the human auditory system, from how we recognize or how we listen to sounds. That's on one hand the field of psychoacoustics, where people have worked for a long time, now getting more and more input from neurosciences, learning more about how our brain works. But for testing, it's been very simple. Okay, here are signals. Can you hear any difference? If you hear a difference, rate it. And you have to do it in a way that it's scientifically valid, meaning that the statistics have a bias. So you have to look to the orders, you need hidden references, double-blind testing, and all this. And that's the way we've done it all the time along. In fact, in the very early days, I didn't have a panel of 20 or 40 listeners away. So the question was, can I hear a difference? And that means repeating the same to get statistically valid results. In fact, if you look at these forced choice double stimulus methods and you do it for several signals, you can already again calculate the probability of getting a wrong positive.
I see. Yeah.
So even that is not that easy. Over time, just since this complete continuation was not possible, people went to a type of testing where you average over different people, which we know is wrong in some sense, because people do have different abilities to hear.
Yes.
So we really would like to get the most critical results.
Yeah, that's fine.
Same thing with the signals in audio, and that's the same if you just do quantization. So the same for CD. There are some signals where it's much more critical. I remember I listened to demos of some piano just fading out into the noise, and there you can hear all the difficulties with your D2A.
Yes.
So,
and the AD conversion, of course.
Yeah, and not right dithering and all that.
Yes, that's right.
So it depends on the signal. So theoretically, we need to test every person on the world for every signal in a statistically valid way. Not possible, so people did the approximation by just setting the conditions as hard as possible within the limits of resources available. And that worked out quite well.
How is the quality of the, or was, of the MP3 encoders at the time? I have a bad hearing, so I cannot hear any difference. So, but I can remember in the 80s that some people complained about the quality, but there were always people complaining in the audio world, so I'm not surprised that some people...
In the 80s they couldn't complain about MP3 because the file ending was only set in 95.
Okay.
But still, yes, if people know what to listen for,
that's the point.
yeah, then you can find, and it depends on the bitrate.
Of course.
But there is some deficiency, small deficiency in the standard, which really goes back to some political compromises. So the so-called pre-echo artifact, castanets, was our test signal. There, people who are trained enough or have good hearing abilities can hear some difference at any bitrate.
Oh, is it?
We corrected that only with AAC. AAC is better. AAC, given high enough a bitrate, is good enough that even the golden ears for all the test signals get into trouble.
Didn't you fall into a trap that you concentrated just on these castanets because people complained on it, and maybe that's why the broader range of sound quality was degrading more or less, just because you had so many complaints about the castanets. This must be the best that I can do, and that's why trading the quality of because, well, what's the probability that you hear castanets in the sound? So,
no, in fact, the castanets were a known problem, but we had enough ideas what to do about it, that it was reasonably good. There were other signals before we finalized the standard in the earlier systems, which were much more difficult. The famous, infamous Tom Steiner, Susan Vega. That's why she loves to be called mother of MP3.
I see. Oh.
Because really, when my PhD work was nearly done, and I thought, okay, I got reasonable quality on all these difficult test signals, which even early on we tried to find. And then there was this item, and her sound got not a bit distorted, but destroyed. That's low bit rates. You could, of course, go to very high bit rates and it's fine again, but at very low bit rates, it got destroyed. And in fact, this came down to some inadequacies in the psychoacoustic theory of that time.
I see.
It was just before I went to Bernard's, so I remember together with Jim Johnston, I went to Joe Hall, famous there in the US for doing psychoacoustics research, and asked him, look, that's the problem we got, something must be wrong, because we could switch off the psychoacoustic model and things got better, which was clearly a sign that we had something wrong.
Yes, that's right. Oh, that's fun.
And he said, is it this, could it be that tonality is frequency dependent, not just broadband? And he said, I have no idea, you have just to test it.
Very good, very good. So you could actually...
that worked out.
So you could add to the theory.
Yes, we have theory in the and this continues until today. In fact, we have similar questions in spatial audio these days, where some effects are known to people working in the area, but very in terms of anecdotal evidence. So you won't find anybody disagreeing, but you won't find many experiments showing these effects, and even less giving you quantitative data. And if you look, for example, at replication of sound in a room to get the highest qualities, like with wavelet synthesis these days, we know that the reflections in the room can destroy the illusion. This sentence is easy. We don't have any quantitative data.
Interesting.